Hello everyone, welcome to Pre-Algebra. So this is the last module that we will work on, and this module is going to be on some basic geometry. So the first few sections are fairly short, so I kind of combine them together. So in this particular lecture video, I want to talk about sections 10.1, 10.2, and 10.3, which deal with the perimeter of geometric objects, the circumference of a circle, the area of geometric objects, and volume. In volume, we're only going to focus on what's called a rectangular solid, which is like a box. So what I did was I actually found some equations for all these geometric figures online that you can refer to. So I posted them here on the first page, so you can always go back to these if you want to. But I'm going to rederive them as we go through the lecture. Okay, but you can refer back to these whenever you need to. Okay, so let's start with perimeter. So actually, before I even do that, let me describe what a polygon is. So a polygon is a closed figure made up of line segments. So something like this, as long as they're straight line segments, that would be a polygon. Okay, assume that connects there. And many of the geometric figures we talk about, like squares, triangles, trapezoids, those are also all polygons. Okay, so what is the perimeter of a polygon? It's basically the distance around the object, right? So the perimeter of a polygon is the distance around it. So for example, let's say we have this polygon. Okay, and let's say we're given some measurements. Let's say this length right here is 2 meters. Let's say this length is 3 meters. This is 7 meters. Say 5 meters and 1 meter. And I want to find the perimeter. So find the perimeter. Okay, so all I need to do, I can start anywhere, right? Just be careful you don't double count. And I'm just going to add up these lengths, right? 3 plus 7 plus 5 plus 1 plus 2. All you're doing is you're summing the lengths of each of the sides. So this will be, I'll start with a 3, 7, 5, 1, 2. I want to add these, right? Sum them up. So 3 plus 7 is what? 10. Plus 5 is 15. Plus 1 is 16. Plus 2 is 18. 8 carried a 1. And it has units, right? The units are meters. So the perimeter, I'll call P here, the perimeter, is equal to 18 meters. So that would be my answer. What if you have something like, let's say a rectangle. Okay, so again, find the perimeter. Let's say I have this rectangle and I'm told that the length is equal to 5 feet and the width is 3 feet. And I want to find the perimeter of that rectangle. Okay, so first thing, we know that with a rectangle, if this side, right, if this length is 5 feet, then this side must also be 5 feet, right? They're the same exact length. So this must also be 5 feet. And in the side opposite, the one I labeled the width, that also has to be 3 feet. So then the perimeter is going to be 5 plus 3 plus 5 plus 3, and that's equal to 16, and it has units of feet. So that would be the perimeter. So 16 feet in that particular example. Now in general, because a rectangle, right, is a shape we know, we can define the length in general as L and the width in general as W. We can actually come up with an equation for the perimeter. So another way of doing this, I could have said, okay, in general, so I can do this more generally is what I'm trying to say. Let's say this is my rectangle. And let's say this is length L in general, right? In our particular example, it was 5 feet, but it can be anything. And let's say this is the width in general. So we know that the perimeter is going to be L plus W plus L plus W. And an easier way to write that, and you guys will learn more about this when you study, when you get into Algebra 1, but I could also write this as 2L, 2 times the length plus 2 times the width, or I could even write it like this as 2 times L plus W. So let's see if it works in this example, right? In our example, length was 5, width was 3. So we have, let me box this first. So that's the formula. So in our example, the perimeter was 2 times length was 5, width was 3. Remember, order of operations I have to do inside the parentheses first. Well, that's 5 plus 3 is 8. So this is 2 times 8, which is 16. And of course, it has units of feet. Okay, so perimeter is simply adding up around the lengths of all the sides of the particular figure. All right, what about the circumference of a circle? Well, it's kind of like a perimeter, but it's a circle now, right? It's not a polygon. So circumference of a circle. So the distance around a circle is called the circumference. The distance around a circle is called its circumference. So if I draw a circle, right, let me see if I can do this. Sometimes it's difficult to do this on an iPad. See, this is my circle. If I start at some point here and I measure all the way around, I'll do this in red. So if I measure this length all the way around like this, that's going to be the circumference. All right, what else is true about a circle? Well, if I measure from the center out to the edge, that's called the radius. Usually we denote that by R. And if I measure from one side, go through the center all the way to the other side, that's called the diameter. So from here to here, all the way to the other side is the diameter. Let me draw that better. So all the way to there, that's the diameter. Usually I'll call that D. Let's call the circumference C here. Okay, so a couple of things. First of all, the diameter, so D, is equal to twice the radius, right? It's 2 times the radius. Or if you want, sometimes you need to find the radius, and that's going to be, if I divide both sides by 2, right? I could solve that for R, divide both sides by 2. It's the diameter divided by 2. It's a half of the diameter. Now the circumference, so that's C here, it's going to be equal to, you can either write it as pi times d, right? So it's pi times the diameter. Or since we know the diameter is 2 times r, you can also write this as, I'll say, or, you could say pi times 2r, but we usually write it in the order as 2, then the pi, then the r, right? Because remember d here, this diameter, is simply 2 times r. And I'm just rearranging the order because I'm multiplying everything. Usually you'll see the formula as 2 pi r, or pi d, either way. What is pi? Well, pi is an irrational number, right? And so we don't know its full decimal expansion. It never repeats, it never terminates, right? No one actually knows the full expansion. I think computers have calculated it to like trillions of places, but no one knows the full expansion. So we're going to estimate pi. We're going to say it's approximately, so these like squiggly equals mean approximately. If we're using a decimal value, we'll say it's around 3.14. If we want to estimate it using a fraction, we'll say it's around 22/7. Okay, so either one's fine. But they're both approximations. They're not exact. Okay, so for example, let's say I want to find the circumference. In this case, I want to use pi is approximately equal to 3.14. Okay, so here's my circle. And let's say it has a radius of 3. Okay, so again, when you see that picture, you notice, oh, this is the radius, right? The radius is 3 meters because it's going from the center out to the edge. So for the circumference, why don't I just use the formula that involves a radius? So that's going to be 2 pi r. So if I plug in r here, I have 2 times pi times 3. So basically this is 6 times pi, right? Or 6 times around 3.14. So I need to do this out somewhere. Again, you can check it with a calculator. There's one topic later when we talk about Pythagorean theorem that you will probably need to use a calculator to estimate answers. But for now, we can still do this by hand, right? So 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. And I want 2 places. So this is going to be 18.84. And then it's in meters, right? Because it's a length. It's a length around the entire circle. So it has the same units, meters. Okay, here's another example. Let's say I want to find the circumference again. And now I want to use pi is approximately equal to 22/7. So I want to use that fraction approximation now. And let's say this is my circle. And let's say I'm given this information now. The length from one side through the center to the other side. Let's say it's 28 feet. So immediately you have to recognize, well, that's diameter, right? So d is what's equal to 28 feet. If I wanted to, I could find the radius and just use the same formula that I had, or I could use the formula for the circumference that involves the diameter. Remember, the other formula is, instead of 2 pi r, it's also equal to pi d. Why don't we just use this one since it involves the diameter, and we have the diameter there. So we're estimating pi as 22/7, and d is going to be 28. So we just need to multiply those together, right? Well, I can simplify this a little bit, right? 7 goes into 7 once. 7 goes into 28 4 times. So this is just going to be 22 times 4, which is 88. Right? This is 88. So this is 88. And then units are feet. So the circumference in this case is 88 feet. Okay, another example. Find the perimeter. And let's say this is the object. Let me see if I can draw that better. It's hard to draw. This is supposed to be half of a circle here. I'm trying to draw. Something like that. Okay. So, and let's say you're told that this length is 3 feet. This length is 5 feet. And this length is 4 feet. So I want to find the perimeter. So by that I mean this distance, right? Here, along here, around half this circle, and then along this straight side. So the hard part here is to figure out what this length is, right, of the semicircle here, this half of a circle. So this is a semicircle. Well, basically, its length will be half of the circumference, right? So the length, let's call this length L, it's going to equal half of the circumference C. And we're given the diameter, right, is 3 feet. That 3 feet represents the diameter. So let's figure out what L is first. So this is going to be L, that length is going to be 1/2, and then the circumference is pi times d. Okay, and let's say we want to use 3.14 for pi. So this will be L equals 1/2 times 3.14 times 3. Okay, if you want, you could write 1/2 as a decimal. That's just going to be 0.5, right? Times 3.14 times 3. So multiply all that together, and you're going to find that this is equal to 4.71. Here, if you want to save a little time by using a calculator, that's fine. So 4.71 feet. So now the perimeter is going to be this length, 5 feet, plus half of the circumference here, right, for the semicircle. That's the 4.71 that we just found, plus 4. Right, so it's going to be 5 plus 4.71 plus 4. So if I add those together, this is going to be 7.1, and then what is that, 13? So the perimeter is equal to 13.71 feet. And that would be the answer. So that would be the perimeter of that object. Okay, now I want to talk about area. So first of all, let's list the formulas for the different geometric figures that we know for area. So I'll start with rectangle, right? So if we have a rectangle, and let's say it has a length and a width, right? So L is the length, W is the width. Then the area, I'll just say A is the area. The area of a rectangle is length times width. It's just L times W. Okay, and if you forget, you can go back and look at that that sheet that I posted on the first page. What do I mean by the area? I mean like the two-dimensional shaded region in here, this area. Okay, next object is a square. So for a square, it really is like a special rectangle where the sides are all the same length. But usually what people do is they just call this length S for side S. So then the area, so this is, S is like the length of a side. So the area for a square is simply length, which is S, times width, which is S, but then we can write that as S squared, right? Because it's S times S. So this is for a rectangle, this is for a square. What about a triangle? So a triangle, which looks like this, has a height, which is the distance. Actually, let me talk about the base first. Has a base, which is this distance right here. So B is for base. H is the height. And the height is the distance, the perpendicular distance from the base up to the apex here, or the peak here. So this would be like the height H. Or, I mean, you can draw a triangle different ways, so you have to be familiar. Like, if you have a right triangle, which has a right angle, a 90-degree angle, so that means this angle is 90 degrees, then this is the base, and this is the height. And you could even have a triangle that looks like this. So in that case, this would be the base, right? And then this would be the height right here. So this would be the height H. Okay, in all these cases, the formula for the area of the triangle is area is going to be 1/2 the base times the height. So 1/2 base times height. Or some people will just write it like this, right? If I multiply those out, I'm going to get B times height, base times height, over 2. That's the other way of saying it. So that's the area of a triangle. Next figure is a parallelogram. So this is a figure where the opposite sides are parallel, meaning they never intersect. If you extend them forever, they go on and they never cross. So in this case, right, this side is parallel to that side, so if you extend them, they will never cross, and this side is parallel to this side, so if you extend them in both directions, they would never cross. So for a parallelogram, this is the base, and then the height is just the perpendicular distance between the two bases. So it would go like this. Basically, like this would be the height H. So the area for parallelogram is simply going to be the base times the height. And then a trapezoid it looks like this. So two sides are parallel, like this side and this side. The other sides just connect them. They don't have to be parallel. One of these parallel sides we're going to call base 1 and the other one base 2. So the subscript 1 just means like base 1 and the subscript 2 means base 2. And then the height is, again, the distance, the perpendicular distance between those two bases. This would be the height. So H is the height. So the formula for the area of a trapezoid is it's the height times the sum of the bases. So I have to put that in parentheses. So B1 plus B2 all divided by 2. or you could say 1/2 times the height times the sum of the bases. So let me box that. So it's the height times the sum of the bases divided by 2. And then the only other formula the only other figure I want to look at for area is a circle. So a circle, right, has radius r, and the area of a circle, so r is the radius, is simply going to be pi times r, but we write that as r squared. So it's pi r squared, pi times r squared. That would be the area of a circle. Okay, so let's do some examples here. Let's say I want to find the area. And this is my geometric figure. Let's say it's a triangle that looks like this. And I'm told that this length is 4 centimeters. And let's say, I'll just dash this in here. I'm told that this height is 9 centimeters. Okay, so remember, the area of a triangle is base times height divided by 2, right? Or 1/2 base times height. So in this case, the 4 here, this is really the base, so that's b, and the height is the 9. So now I can just plug in, right? This is going to be 4 times 9 divided by 2. So that'll be 36 divided by 2, which we know is 18. And for the units, since it's an area, it's going to be the unit of length, which was centimeters, but then we have to square it. Okay, area is always going to have the units of length squared. So in this case, it'll be centimeters squared. So that would be my answer. The area of that triangle is 18 centimeters squared. All right, what if my object is a square like this? And let's say each side is 10 inches. Well, the area of a square, remember, is going to be s squared. So this is like our s, right, the side length. So that's just going to be 10 squared, but we know that's 10 times 10, which is 100, and it has units of inches squared. Okay, and then let's say a trapezoid. Let's say you're told that this is 4 centimeters, this is 6 centimeters, and then this height is, say, 3 centimeters. So it doesn't matter which base you label B1 and B2. So I'm just going to say the first one is B1, the top one is B1, the bottom is B2, and then this, of course, is my height. So then we simply plug into the formula, right? It's going to be the height times B1 plus B2, all divided by 2. So in this case, it'll be 3 times 4 plus 6, all divided by 2. So using order of operations, right, this is going to be 3 times 10. I have to do in parentheses first, divided by 2. I could simplify a little bit here, right? 2 goes into 2 once, 2 goes into 10 5 times. And then 3 times 5 is going to be 15. And again, it has units of centimeters squared because it's an area. So the area of that trapezoid there, so like this region, this two-dimensional region, is going to be 15 centimeters squared. Let's say this is my object, a circle. and I want to find the area, and I'm given this information. Let's say I'm given that this is 16 feet. Okay, so remember the area of a circle is pi r squared. So here we have to be a little careful, right? What information are we given? Well, we're given the diameter. The diameter is 16 feet. And we know that the radius is the diameter divided by 2, right? It's half the diameter. So first I need to find the radius. So this is going to be 16 divided by 2. That's going to be 8 feet. Now that I have the radius, I can plug in. Let's assume we want to use 3.14 for pi to estimate pi. And now this is going to be 8 squared. So then I can multiply this out. Well, 8 squared is 64. So this is 3.14 times 64. And then I can do that on the side here, or you could check this with your calculator if you wanted to. So this is what? 16, 1. 4 times 1 is 4, plus 1 is 5. 4 times 3 is 12. 0. 6 times 4 is 24. Carry the 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. So now I add 6, 9, 10, another 10, and then a 2, and then I need 2 decimal places, right? So it's going to be 200.96, and then it has units of feet squared, again because it's an area, right? So the area of that circle is around 200.96. We approximated because we approximated pi. So around 200.96 feet squared. Okay, and then the last thing I want to talk about is the volume. And in particular, we're just going to look at one object, the volume of a rectangular solid. So the volume of a rectangular solid. What is a rectangular solid? You can think of it as a box. So if I draw, see if I can draw this box here. So this box has a length, right, L. It has a width, W, and it has a height, H. Right, so L is the length, W is the width, and it doesn't really matter what you call the length, what you call the width, and what you call the height. And H is the height. So the volume, which I'll call V, is the volume of a rectangular solid of a box, is simply going to be the length times the width times the height. You just multiply those three together, and that will give you the volume of that box. Right? And that's the only geometric object we're going to talk about when we're dealing with volume. Okay, so let me end this section, or these sections, I guess, 3 sections, by looking at a couple of examples from your homework, from my open math homework. Okay, so in this example, we're asked to find the area of that parallelogram. So remember, the area of a parallelogram is it's equal to the base times the height. So in this case, the base is going to be that value 54, and then the red line here, this is the height, right, 43. So the area is going to be 54 times 43. Okay, so I need to multiply this out. So this is what, 12, 1, 15, 16, 0. 4 times 4 is 16, 1, 21. So it looks like 2, 12, 3, 2. So it looks like 2,322. And they didn't give us any particular units, so it's just like square units. You can just leave it as 2322. Okay, in this example, we want to find the area of that triangle. So remember, the formula for the area of a triangle is base times height divided by 2, right? Or 1/2 base times height. In this case, the base is the 7, and the height is the 5 there, right? So this is going to be, let's see, 7 times 5 divided by 2. So this is 35 divided by 2. If you want to write this as a decimal, we can work this out. So this is what, 1, subtract, bring down to 5, 2 into 15 is 7, 1, and then bring down to 0, 2 into 10 is 5. So this is going to be 17.5. Again, square units, they didn't give us the units here, so we can just leave it as 17.5. Okay, in this question, I'm given a circle, and I want to find the area of a circle. Well, remember the formula for the area of a circle is pi r squared. Well, in this case, we're given the diameter, right? The diameter is 8. So the first thing we need to do is find the radius. Well, if the diameter is 8, the radius must be the diameter divided by 2. So that's going to be 8 divided by 2, which is 4. So the radius is 4 units. So now I can plug in. Assume that we're going to use 3.14 for pi. So it's 3.14 times 4 squared. So order of operations, I do the 4 squared first. So this is 3.14 times 16. So then I can work this out on the side here. So this is what, 24, then 8, 18, 0, 4, 1, 3. So 4, 12, 10, 1, 5, 2 places. So it looks like the area in this case is going to be 50.24. And again, it's square units. Like if this were, they didn't give us units again here, but if they did, let's say this were inches, then this would be inches squared. Okay, so it's always going to be square units. Okay, in this question, we want to find the area of the figure pictured below, so the area of the L. Well, to do that, we kind of have to break up this figure, right, into two. We can really create 2 rectangles out of this. If I extend, I can do this one of 2 ways. Let me do it this way. Let me extend this side over. So I have rectangle 1, rectangle 2. Okay, this one, rectangle 2, the length is 9, the width is 2. That's easy. Rectangle 1, I have to figure out, well, let's say this is the width is 4, right? But I need to figure out this, like the length. Well, if this whole length is 12, and I know from just from here to here is 2, this must be the difference, right? This must be 12 minus 2. So I guess this length is going to be 10 centimeters. So here, I'll split it up. I have this rectangle now, which is 4 centimeters by 10 centimeters. And then I have this rectangle, which is 2 centimeters by 9 centimeters. So I'll call this 1, I'll call this 2. So I can find the area of rectangle 1 by just doing length times width, right? Say this is the length, this is the width. In this case, this is the length, this is the width. Usually we call the longer side the length, but again, it doesn't really matter. So this would be 10 times 4, so that's going to be 40, and it's centimeters squared. And an area of the second rectangle is length times width, so that's going to be 9 times 2, which is 18 centimeters squared. So what's the area of the entire figure? Well, I just add the area of those 2 rectangles together, right? A1 plus A2. So the total area is going to be, I guess, 40 plus 18, which is what, 58 centimeters squared. So sometimes you have to do a little extra work and split it up into known figures, right? In this case, We know how to find the area of a rectangle. We could split it up into two rectangles. Okay, in this question, I'm given a triangle and I want to find the perimeter. Well, the perimeter is just the sum of those sides, right? So the perimeter is just going to be 13.3 plus 16.8 plus 17.8. So I'm going to line these up vertically, make sure I line up my decimal points, and then just add them together, right? So 3 plus 8 plus 8, this is what, 11, 19. Carry the 1, that's 4, plus 6 is 10, plus 7 is 17, and then 1 plus 1 plus 1 plus 1 is 4. So it looks like the perimeter is 47.9 units. Again, if these had units, like if these were, say, meters, then this would just be meters, right? Because this is the distance around. So that would be the answer. Okay, in this example, we're given a circle, and we want to find the circumference, right? The distance around the circle. So, again, the formula for circumference is either going to be pi times d or 2 pi r, right? We can use either one. Well, in this case, we're given the radius, right? From the center out to the edge is the radius. So why don't I just use 2 pi r? So 2 pi, we'll use 3.14, and in r, in this case, is 10 centimeters. So if I multiply these together, it doesn't matter what order, so I could say this is 20 times 3.14. And then let me do that on the side here. Again, you could check this if you want with a calculator. So this is going to be 826. And I have 2 decimal places. So it looks like the circumference is going to be 62.8 centimeters, right? It's just the length measurement because it's a length around that circle. Okay, and then one more question. This question says a small box measures 4 inches by 10 inches by 3/4 inch high. Find the volume of the box. Okay, so here let's see if we can draw this. So let's see, 3/4 inch high, and it's really long, right? Something like this. So let's say this is 4 inches. This is 10 inches. And then the height is 3/4 inch. So that's clearly the height. It doesn't really matter what we call the length and the width. Let me call this the length and this the width. So remember, the volume of a box, of a rectangular solid, is length times width times height, right? So this is simply going to be 10 times 4 times 3/4. Okay, so if you want, we can write these as fractions. 10 over 1 times 4 over 1 times 3 over 4. I can simplify. I can cancel the 4's here, right? Just 1 and 1. So then multiply numerators. 10 times 1 times 3 is 30. And denominators, 1 times 1 times 1 is 1. So this is simply going to be 30. But then it has units of inches. It's a volume now, so it's going to be cubed. So it'll be inches cubed. So 30 inches cubed would be the volume of that box. Okay, great. So that's it for this video lecture. Next time we'll look at similar triangles. We'll do a few other things with geometry. Great, thanks.